Welcome to the Twin Cities Business Show. Did you know there's a company that's 3D printing rocket fuel in Golden Valley? We talked to Chromatic's founder and CEO, Cora Leibig, about the innovative 3D printing solutions that they've brought to American manufacturing and what they're doing to help fight America's missile shortage. Welcome to the Twin Cities Business Show. We are here today with Cora Leibig, the founder and CEO of Chromatic 3D Materials. Cora,
Thanks.
welcome to the show.
Thanks so much for having me. Happy to be here.
Very excited to have you. So we're going to start by talking about 3D printing rocket fuel.
Nice.
So you've brought in this beautiful mold that looks like the rocket fuel that you 3D print in a solid state.
Yep.
Why do we need solid state 3D printed rocket fuel?
Sure. So first of all, rocket fuel comes in two forms, liquid and solid. And if you think about your standard fireworks, you're certainly not plumbing like oxygen into your fireworks. You have something that's solid that you light on fire. That's what solid rocket fuel is. And so most rockets are powered by solid rocket fuel, actually. So, and they often go into a lot of weapons applications and things like that. So what you do is it's sort of like a clay consistency. So you have this shock resistant rubber matrix that you load as much of the stuff that will light on fire, sort of the powdery substances that you load into that. And that's what turns it into solid rocket fuel. So traditionally, the way it's made is that you pour this kind of concrete mixture into a mold. And what we've been able to do is prove that we can 3D print it. And most importantly, 3D print it with the same kinds of materials that people have been using to mold it with. So, and why that's important is that means that it has all the right shock resistance and energy content that you expect in a rocket. So why do you need shock resistance? Because when these things launch, it's under a lot of mechanical stress. The other thing is that it burns, so it's going to burn from the inside out. When it burns, if anything breaks from the pressure of combustion, then that causes an explosion. So you want it to be a controlled burn, and so you need it to be nice and strong. And what dictates how far a rocket can go depends on how much of the energetic you can incorporate. And so that's what we've been able to do.
Wow. So you have a 3D printing business in Golden Valley. You guys are printing a bunch of amazing manufacturing parts. And one day you get into this. Can you explain to me the process of how you get into the rocket fuel business from the sort of manufacturing business that's more of the core of what you guys do?
Sure. So we specialize in 3D printing kind of industrial strength rubber. So I have an example here where it's a tire tread. So we were literally 3D printing like rubber tire treads. Also parts that go into clothing, industrial parts like this is for a vent, medical parts. So you find these rubber materials everywhere. And so you're always, when you have a technology expertise, you're always looking for what are the right applications to get into. And it just so happens that one of my investors is the founder of Relativity Space. So he's a rocket guy. He founded the USC Rocket Club, or was really active in the Rocket Club. And so he and I were visiting University of Southern California once, and he said, let's go through the rocket lab. We went through the rocket lab, and he said, oh, see how they make this rocket fuel, Cora. They mix in a curative, sort of like what you've been doing with all of your other 3D printing. And I just asked, well, what kind of curative is it? And it turns out that the chemistry that you use for making this standard rocket fuel had been the chemistry that we've been printing for years. And so we're very unique in the 3D printing industry for knowing how to print things that cure. That's really our specialty, and how to preserve the mechanical properties. And so when you look at what is needed for rocket fuel, that's what we had already. So what we had to do is figure out how to load in the energetics. Now, the other thing to know is why does anyone care about 3D printed rocket fuel? Well, it turns out, I mentioned that these burn from the inside out. Mm-hmm. It turns out that the geometries that you can make completely determine the thrust profile of a rocket. You can design it so it can go super fast and then cruise and all these different things, just given the geometry of how you configure the rocket fuel. And so 3D printing is good at being able to access geometries that you can't access when you mold. And so when we were able to go to the Department of Defense essentially and say, hey, we've got a way to print rocket fuel without losing any of the material strength or the shock resistance, that started to get their attention.
So this is a unique, novel chemistry and approach that you guys are first to the market on.
Yes.
Really fascinating.
Yes.
How do you go to the Department of Defense and pitch something like that? Like, how does that work?
It's a lot of networking. Mm-hmm. So
just go to happy hours near the Pentagon?
Yeah, basically. No, you really, you have to order pizza at the right time.
Yeah, exactly.
No, so first, I took advantage of a number of local resources. There's a defense alliance in town. Minnesota SBIR also has some defense networking.
What does that stand for?
So SBIR is the Small Business Innovation Research Funds. So they're funds that small businesses can get to access federal funds and federal research objectives. And there's solicitations that go out from the federal government saying, hey, we're looking for people with technology that looks like this. And when you get those solicitations, you basically get names of people to go reach out and talk to. And so that was one way that we went out. So we started to go to conferences. And at every conference, you're just starting to find your way into the network. And believe it or not, I think it's pretty, believe it or not, the community of people who understand rocket propulsion is a pretty small community.
I do believe that.
So it's not very difficult to find the 50 to 100 people who need to hear your story. You start to, you go to one or two conferences that might be duds, but there might be at least 3 or 4 people there who can point you to the right place to go. So now I'm going to a number of, there's probably about 4 rocket labs across the country, in the Mojave Desert, in New Jersey, in Huntsville, Alabama, where you just start to find the people who really want to understand what we're doing here.
Yeah. So it feels like there is this interesting cluster of sort of defense and defense adjacent companies that are kind of ascendant in Minnesota right now.
Mm-hmm.
I mean, we have the Defense Innovation On-Ramp Hub that's based here. Northwind is here, and there's been some other things. Do you feel like there's a larger sort of ecosystem or cluster that's kind of growing in Minnesota?
I think thanks to the Minnesota national security ecosystem efforts from Bill Harper, Betty McCollum, groups like that, there's a lot of deliberate action to try to pull stuff together. I think a lot of it was already here, but sort of not necessarily coordinated. And I think part of what some of these groups are trying to do is get ourselves a little more coordinated so we can have more, we can help each other more and point out where we can help each other. So an example of how that's been able to help me, we're setting up a place where we can test our rockets. So we can't, believe it or not, we can't really test our rockets in Golden Valley. Yeah. So we need to get out of the Twin Cities metro. And so through the ecosystem, we've been able to locate a great place to do some testing. And, thanks to people helping others, it's in our government's interest to make sure that Minnesota's, really bringing some defense technology to the table.
So that's going to be at the Northwind facility in Rosemount, right?
Somewhere else? No, it's somewhere else. Oh. So there's going to be a press release about it in a couple of weeks. But yeah,
breaking news.
Yeah,
where's it going to be? Can you tell us?
It's going to be in Camp Ripley.
That's very exciting.
Yeah.
Well, you heard it here first.
That's
folks.
Right. Exactly.
Really exciting. Okay. Well, I want to dig in a little bit more on just your company because I think what you do is so interesting.
Sure.
Prior to getting into rocket fuel, you did, I think, what a lot of people call sort of additive manufacturing type of stuff. Can you tell people a little bit about what is that and how 3D printing is so helpful for that general industry?
Sure. So there's, really it gets into how do we make stuff, right? And so how do we make stuff is almost like a question like where does chicken come from? There are, when we make stuff, you have machines that form materials to make the things that we know and love and contact every day. I'm glad to say that we still live in a material world. This table is real, and one of the fortunate things, back in my history, I worked at Dow Chemical. And when you work at a material supplier like Dow Chemical, you start to look at a table like this and say, well, I know what kind of lacquer's on top. I know what went into how the wood had to be finished. And in fact, my career has taken me to, I've been at paper and pulp mills. I've been to apparel factories. I've been to toilet paper factories, believe it or not, for this kind of application. And it's, the way we make things is incredible. And so 3D printing is just yet another way to make stuff. And the reason why 3D printing stands out is that you can have with a single machine a way to make a lot of different things, where a lot of other equipment, usually you have to set up for a particular item that you're going to make. And so what a 3D printer gets you is a single investment in a machine that can make a lot of different things. It's sort of like getting a drill press. And so now what's special about 3D printing is that it can access things that we've never been able to make before. And so it's a tool in your toolbox for how to manufacture. So what I love about additive manufacturing, what brought me into it, is that ironically, my kids do speech and debate. And so I heard a speech about additive manufacturing, and I said, I'm hooked. As a high school student. High school student.
No way.
And so you never know. You should sign up to judge. They always need judges.
What a pitch.
Exactly. So what I loved about it is that usually, if you think about the way things are made, we have stuff getting shipped all over the place. We might make material make some material in Texas, and then we ship it all the way over to China, and then we put it in one factory, and then you ship from that factory to another factory in India, and you make another formation, you move it back to the US, and it's a huge waste that we use these huge steps. And the reason why we do that is because these machines are made for only doing one thing. Mm-hmm. And so what I love about additive manufacturing, what drew me to it and really was sort of like falling in love, was that here you have a machine that can just make a lot of different things. And so and for not a lot of added cost, a printer is relatively cheap compared to an injection molding machine. And so then I started looking at additive manufacturing and started to see where there were some problems. But what I always like to think about when I see problems is say, well, and do I have some ideas on how to solve them? And in the case of 3D printing, I said, if we could print curable stuff, and I know how to adjust the chemistry, and I can find the right people who know how to adjust the chemistry and adjust the equipment, then we'd make some progress on this. So that's really what brought me into it.
Fascinating. Okay, so you're working for Dow Chemical, and you're living in Texas, and you get an offer to move up to Minnesota.
Yeah.
Tell us a little bit about that, what you were feeling, and how that all went.
Oh, sure. So I grew up originally in New England, and it's from a really big family. And my dad was a computer scientist before computer science is, basically at the dawn of its creation, late 60s. And he was in just a series of startups, one startup after another. Did they make it? No, they did not. And then I went to MIT. And so MIT, you see a lot of startups. And
you're at MIT, what years?
89 and 93.
Okay. So what are you studying when you're at MIT?
Chemical engineering.
Okay.
Yeah. So, so I went into this chemical world, and chemical world is usually like big plants, like in Texas, it's big petrochemical plants. There's not a lot of startups in that field. And so what drew me into joining the startup in Minnesota is that I didn't think that my career was going to create many opportunities for startups. How many people need, polymer scientists for startups? And that was actually the first wave of clean tech, sustainable technology that I was a part of. So I was part of a startup that started in Minneapolis by Sergey and Olga Selifanov, and a lot of ties to Cargill. And so they were trying to build a specialty chemical company. And I looked at it, it had a very nice job in Dow. I looked at it and I said, I don't know if this company will make it, but I want to go for the ride. Do I want to look back at my career and say that I tried it, or would I rather just continue on the path that I'm on? And I said, I'd rather say that I tried it. And the rest is history. So it turns out that company, instead of it, I thought, man, even if I get 3 years, that'd be great. Turns out it went for about 8 years, and I learned a lot about startup, how to develop a technology business, and made a lot of connections. And I fell in love with it. I just loved working in a startup environment. It's a great place to do technology development.
So later on, you decided to start your own business.
Yes.
Talk a little bit about that process and the launch of Chromatic.
Sure. It was about, I would say it was clear that Siggetis was not going to continue much longer. It got bought by European investors, and so it was going to move on. So I was starting to think about, what did I want to do next? And that's when I heard that speech about 3D printing. And so I guess, in the background, just started to work on, what were some concepts and what was missing and what was working. And I think thanks to my experience at Dow, I had a pretty good idea of what materials are used where. I don't know if it's a blessing or a curse, but I can look at something like, plastic bags and say, oh, that's polyethylene. Oh, that's polypropylene. And I don't have to look at the numbers at the bottom. So what I noticed in 3D printing was that there were some huge material families that were missing. And it turns out that the material families that were missing from the palette that people could choose from for 3D printing was actually the department that I led at Dow.
Okay.
So I was like, okay, I know something here. And plus, coming out of a startup, I had some connections to people who were interested in financing, things like that. And so I started out, I worked on transitioning the Siggetis business. And the people who bought it, I said, can I rent a little lab space? And at the start, I just, my oldest daughter was in high school, late high school. And I said, can you help me do some lab experiments and help me prove this out? And I had to buy her a Starbucks every day. That was the payment.
Probably a good deal.
It was a pretty good deal, and God help me if I forgot. So so I started Chromatic basically with a Starbucks every day, and when I meet people who are thinking about founding a company, one of the things I usually say is people focus so much on how to convince investors to invest their money that they forget to think about how to convince yourself that it's worth spending your time on it, because that's the most valuable thing, and the thing that's hard to stop. Once you found a company, it's really hard to stop it, because once you start bringing in other people's money, then you have a lot of responsibility. And so I had a few things that I wanted to prove to myself that would be possible with the technology, and once I proved that, then we started doing some grant writing. Met with Pat Dillon over at the Minnesota SBIR, got a National Science Foundation grant, and that really got our start. So also got some friends and family money. but and was able to hire some of my first employees. So
Wow.
yeah.
So, thinking more about this additive manufacturing thing, right?
Hmm.
It's lower cost, it lowers the logistics. Just can you classify a little bit all the benefits of this to the greater manufacturing sector and how you guys fit into that?
Sure. So with there are a lot of things that standard manufacturing practices do just fine. Um, but if I were to look at, you know, we have this piece of tire track here, tire tread. There are a lot of inventory problems that come out of having to offer a lot of variety. So, as soon as you need to offer a lot of variety and there's a lot of changes that you need to be able to supply, that's when 3D printing starts to make sense. So, in the tire case, it turns out that trucks need to be retreaded, 5 times per tire. So we don't retread passenger tires, but we retread truck tires quite a bit.
Okay.
And in order to be able to retread those trucks, they tire companies have to supply the treads in every single tread design for every single size of a truck tire all over the country. And it's hugely expensive for them. And it's expensive for them to be able to stock everything and put it in place. So the concept there that we were looking at was being able to 3D print those truck treads as they were needed. So that's one value proposition, is wherever you have these products where you have a lot of variations that you need to be able to supply for personalization or customization. That takes you into a lot of medical applications as well. The other place where you start to use 3D printing is where the things that you want to be able to make with it are impossible to make any other way. So I've got this little trinket here where it's striped red to blue, but if you were to look carefully, you can see that the red is actually softer than blue, and it kind of transitions from one to the next. And it's impossible to build a part like that where you have that kind of variation in material without loss of bonding. So we have found a lot of applications for being able to do this, including the solid rocket fuel. And because this is simply something you cannot achieve with standard processes. And so the place where you use 3D printing in those cases is achieving shapes, achieving parts and designs that are impossible otherwise. The trick is figuring out where those impossible to achieve designs are needed. And that's what we happened upon with the rocket fuel. Generally, what I've found is that engineers aren't taught to even know how to think about a design like this. So a big part of since this was one of the features of what our technology can do, a part of what we need to build and develop is the capability for people to even identify when this can help them. So this was actually an exploration with Medtronic and the University of Minnesota, where we did some analysis of mechanical properties across it. And for Medtronic, for a company like that, they have a lot of parts and pieces where they need to go from something that's hard to soft. You need softness to be able to interact with a lot of delicate areas in the body, but you need something stiff to be able to get things there. Think about catheters or other parts like that. So that's an example of where you need a design that you can achieve only with 3D printing, but you can't get other ways.
Fascinating. So over the past few decades, America's seen its manufacturing and industrial base really hollow out.
Yeah.
Do you think that 3D printing could change the trajectory of that at all?
I think it absolutely can. I mean, I think it can allow smaller manufacturers to be economically viable, and I think that's really what the U.S. needs for that. Because really, what we have, our health as a country, comes from our entrepreneurial spirit, and so there are a lot of small businesses and people with ideas on things to make. And if what they need to do is access a 3D printer versus a major injection molding facility in China, it's a good way to do that. The other thing that I think makes 3D printing appropriate is that one of the things that keeps 3D printing from broad manufacturing use is that you're competing against the cost of depreciated capital. If someone's already bought an injection molding machine and they can figure out how to make stuff with their injection molding machine, they're going to keep using it. Why would they invest in a new printer if they've got a machine that can do the job? As soon as you're reshoring, you're buying all new capital. And so when you're starting from a blank slate, then any new manufacturing technology is worthy of much more consideration than if you're battling against something that's already invested.
Really interesting. So there is this you guys have to find ways to almost compete with financial cycles that manufacturing companies are engaged in.
Absolutely.
How do you do that?
You have to look out for the timing. And you have to look for, who's investing, where's new capacity needed. And that's really one of the things that caused this pivot for us into rocket fuel. So we've been always looking for the right application. You see a bunch of different applications right here. And we would always find significant value propositions like this tire tread example. There's significant value propositions there and reasons why it should work and save money and all those things. The difference with the solid rocket fuel is that its timing is now. When you look at, unfortunately, and I might be more plugged into this than most, but it's scary when you see things like the amount of weapons that we sent to Ukraine. Whether you agree with it or not, we sent about 3 years worth of production. And when you think about that number of 3 years of production, that's like everything that was produced for 3 years was sent there. So that means you are you have a backlog of 3 years. When you look at statistics about the 12 days war with Israel, the number of rockets that were intercepted. So if you go back to the Patriot missile and things that are used to defend, again, we within 12 days used about a year's worth of our supply. And it's not just the year of supply. Those factories can't make any more than that. And when you look at how long will it take for us to increase our production of the Patriot missile, for example, the numbers are something like 3 years and several $1 billion that we need to put into it. So when we looked at rocket fuel as an application, that's part of what made it attractive, is that here's a place where, because of the state in the world, because of these conflicts and security issues, we definitely need to build more capacity. And so this is the right time to bring forward a technology that can make the materials that they need, the rockets that they need, without sacrificing performance, and using far less capital to invest than what they've had to use before.
So as you lay that out, it feels like what you would want to do is to expand your industrial capacity and then expand your defense strategy.
Right.
But we've done it in reverse. Should that make people nervous?
Yeah, it should. It's I think, a consequence of our role in the world. So if you look at other countries where they're building up towards a goal of conquest, if you will, then they always build up their weapons before they go and attack. Mm-hmm. Where we're in a situation where, we're engaging in conflicts. We do have the weapons to engage in those conflicts. But I think, where our nation is at is saying, okay, well, if this is the way the world is, where we need to go in and interfere with some of these situations, we better build this back up. So I don't want to get too much into politics on that stuff, but that's, yeah.
Yeah. So it's not just defense, it does feel like it used to be much easier in this country to scale up manufacturing, to build lots
Hmm.
of things very quickly. You look at everything that happened around certainly World War II, but even in the
Sure.
50s and 60s and just building up that industrial base, we could build factories very quickly, you could scale them very quickly. And now it just feels like we could tend to be kind of slow
Yeah.
or we're slower.
Yeah.
How has that happened? And how do you think that a country like ours could even come close to catching up with a country like China that's just doing that stuff much more quickly?
So a lot of it has to do with financial situations. So, again, I'll draw it back to Dow. Dow had its big growth spurts in World War One and World War Two. And it was that the government basically said, hey, we need more raw material supply. Will you build it? And paid for a lot of that building. And if you look at a lot of the statistics, the amount of the GDP that comes from defense has actually gone down as a percentage in our country significantly since the 80s. And so that's really what's worn away. I know that for things like shipbuilding, a lot of our shipbuilding just evaporated because we stopped ordering ships. So,
Makes sense.
so now we don't, now we're scratching our heads wondering how we're going to start building ships again in our country. So and the problem is that when you establish if you establish something like a shipbuilding facility, how many businesses surround that to support it
Mhm.
that have all left? Right. So when you're talking about losing a core capability like shipbuilding, you've lost a core capability like, 10 other types of industries that supported that. And we saw the same thing happen with chips, microchips, right? So we started with it here, but then it left. Now, I've managed to see these situations where other countries have economic policies where they decide it's critical to have that capability. And so, whereas in the US, we believe in a free market. So, if I say, hey, I want to go build a plant, I go to the bank, I go to investors, I go to a private capital market. In other countries, and I've been approached by other countries, they simply say, hey, we'll build that for you. And then you could just ship your stuff back to America. And free money is very attractive.
Mhm.
And so now what that means is that those countries are building up a debt. And that's, and America has also built up a debt, but I don't think the US has had industrial policy or economic policy that supports manufacturing. If you think about our core values, we support innovation, and that's what we have. We have innovation. And I think in our country, we are not, we don't look too kindly at what we call corporate welfare, which is exactly what all these other countries have. And so as a nation, I think if we want to change this course, I think we need to be a lot more comfortable with corporate welfare and think about it less like welfare and more like competitiveness.
Yeah. So manufacturing and defense just can't be left to the free market. There
Yeah.
has to be government involvement and intervention.
Absolutely.
Yeah. So you have a facility in Germany as well.
Yeah.
What is it like operating in that environment relative to the way you guys operate in the US?
It's a lot more difficult to set up in overseas than here. I mean, I've learned a lot from it. Just even seeing how the financial systems integrate is completely different, and that took a couple years to figure out. The interesting thing is that the reason why we started in Germany is that we were getting most of the demand for looking into 3D printing as a tool in Europe. So, and the interesting thing too is I've looked at what happened to the GDP of the US versus GDP in Europe in 2016, and what is it now? And Europe has barely grown, whereas the US has grown dramatically. And so over the 10 years that I've run the business, it made sense to start in Germany, where there's a lot of innovation in manufacturing. They do their own manufacturing. They're very proud of their manufacturing base. That's why we probably had that initial traction there. But the economic health is just not as vibrant there as it is in the US right now.
Yeah. You guys are in a very interesting place as a company. You've raised $17 million.
Yeah.
You're in 2 countries. But it really feels like the scale and the scope of what you could be is gigantic, right? So what
That's
is
the
your
plan.
yeah? So what is your goal for how much you guys want to grow, and what do you sort of see the next 5 years or even 10 years looking like for the company?
That's a really good question. It's, with the defense pivot that we're going through right now, we're going through a strategic process of really determining exactly what does that look like. Right now, what we're working on is we've been working on convincing the Defense Department that this is a technology that they should be looking at incorporating. The next step will be convincing manufacturers of rockets that they need to adopt the technology. And we have a little bit of that going on right now. So what that could look like in the future is either Chromatic is a large technology supplier to defense primes, or it could look like a defense prime ultimately acquiring Chromatic or something like that.
Interesting. Do you have a preferred pathway?
That's a good question. My preference, I want to make a difference in this world. And so I want a path that makes sure that the technology sees the light of day. And that's really what I'm more focused on is making sure that where it ends up is the best way for the technology to succeed. So I joke that Chromatic is my 5th child. So that's really how I think about it.
Yeah. Do you even really feel like you can do long-term planning, or is it just a lot of you make a plan, you read and react, and then you switch and you just have to execute really quickly?
It's always helpful to have a strategic view of where you're trying to end up and what's the best place to get there. So we've definitely incorporated a lot of strategy development. The strategy, probably changes every year, but it's interesting. We'll go through a process of looking at the 10-year goal versus 5 years and 3 years. The 10-year really hasn't changed that much. How we get there is what changes. And so it's useful to have the end in mind and to stay focused on how are we going to get there. As an example, one of the things that I've found in learning about the defense industry is that how technologies are evaluated is completely different from the groups in the Department of Defense who decide what should be used.
What do you mean by that?
The people who decide what is bought in the actual rocket is very different than the people who evaluate what technology should be considered. So it's a gap between the R&D organizations and the purchasing organizations, if you will. And so I'm trying to look very carefully at how to take advantage of, we've gotten a number of government contracts that we're working through, how to make sure that the success we have there takes us towards the goal of actual implementation and isn't just a curiosity that's on a research shelf somewhere.
Yeah. So to create things like 3D printed rocket fuel, right?
Yeah.
You have to have a desire to solve currently impossible to solve problems, right?
Mm-hmm.
And I would imagine you're thinking about future currently impossible to solve problems right now.
Yeah.
Can you lay out what some of those might be?
A very easy one is help a rocket go 20% farther. And that's, with the given diameter. So that keeps our troops out of harm's way, right? Another example is, hypersonic weapon design. So hypersonic rockets, as I understand it, it's something that Russia and China have in the field, and the U.S. really doesn't. So to make a hypersonic rocket work, you need to be able to get this geometry right, and you need to be able to, you need to be able to integrate the full system. And that's an example of something that we are, that we're looking at.
How could we get a rocket to fly 20% further? Like, what would that actually take
So,
technologically?
okay, very easy. Very
you just
easy.
lit up.
Very easy. So right now I have this example, and this is a typical geometry of rocket fuel. So the reason why you have the star in the middle is that when you light it on fire, you want to access a certain amount of surface area, and that surface area determines how fast it's going to go. If you can create more surface area, then it'll go even faster at the beginning. So the problem is that we just took out a big chunk of place where we could put rocket fuel. So if instead you use a system like this, where it's just sort of a narrow hole, but you're able to vary how hot, if you will, the powder is by location, then you can achieve the same thing you did with the star, but, in using a lot less space. So you can make it so instead of trying to access more surface area, you just say, okay, I'm going to include ingredients that fire faster. And so then I don't need to take up so much space with space. And I can pile more fuel in the rocket, and so that it can go farther.
Wow. So why doesn't that exist right now today?
Because they didn't have Chromatic.
So you guys are, you think, on the road to being able to solve that problem?
Yes, absolutely. No question.
When do you think it'll be done?
It's we'll be doing a number of demonstrations in the next 12 to 18 months. And so now all of these things always require steps. So first you have to demonstrate it. So I think that primary demonstration will happen. Our target is really within the 12-month range, but then you need to prove it out for particular rocket systems, right? So then you have to say, okay, exactly which rocket are we trying to put this into and prove it out there. But that's what we're doing.
So you guys are on the ground floor of this Camp Ripley program. Can you tell me more about your role in it and what is that going to be?
I don't know all the angles of what's happening at Camp Ripley, but what I know is that Camp Ripley is a place where we do a lot of training of troops, and so it's a place where you can have a firing range, and that's essentially what we need to be able to do to test things like this, is to put the rocket on a stand and measure the forces, and you need to be able to light it on fire and measure. And that's what we're able to do at a firing range like Camp Ripley.
Got it. But will you actually be shooting rockets?
No, we do not do flight testing.
Okay.
So flight testing is something that usually you have to go to very specific places in the country to do.
Probably further away from Gull Lake than that is.
Yes, exactly.
Makes sense.
Exactly.
Really interesting. I want to know a little bit more, digging into your background a little bit. So
Sure.
How does an 18-year-old decide I want to do chemical engineering at MIT?
I loved math and I loved chemistry.
Okay.
So I've always loved math. And so the way I've approached my life has been, well, I'm going to try this and see what happens. I had a teacher in high school who said, have you thought about going to MIT? You should think about going to MIT. And the ironic thing is that my dad went to MIT, but no one ever suggested that I should think about it. So until that teacher did. And
what was your teacher's name?
Shirley Wilson.
Do you think Shirley knows that she changed the trajectory of your life?
I don't know. I'm not even sure whether she's still living, but I did write her a letter, maybe a few years into my career. But yeah, that got me to MIT. MIT is an amazing place. I loved my time at MIT. While I was at MIT, that made me want to go get a PhD. So, and the way I figured that out is I started interviewing for jobs when it was time to graduate. And I just started asking the people who were interviewing me, like, well, tell me about your job. What's your job like? What degree do you have? And the people with the interesting jobs had PhDs. So I said, I guess I'll do that.
So then you go get a PhD. And what are you studying in your PhD?
I studied what's a field called polymer science. Technically, my degree is in chemical engineering. Polymer science, if you think about a typical plastic, anything you would think about as plastic, essentially what that is a long chain of carbon atoms. And I studied how it moves, how they flow, and things in physics about polymer chains. So
then what brought you to Dow? So was Dow your first job out of school?
Yeah.
So what brought you to there? Why did you decide, this is where the direction I want to go in?
I was looking at a number of positions, and my thesis advisor for my PhD had been working with Dow as an advisor, and Dow was looking for new talent. They had hiring freezes for like a decade or something like that, and so my advisor pointed me towards them. I looked at a number of different jobs that were. The ironic thing is that within 5 years after I graduated, all of the other jobs I was considering had, their departments had all been closed. So I was looking at DuPont, looking at Mobil, and it turns out I chose the more stable company, and I don't think I had any idea at the time. So,
so much about your background, the way you grew up, where you landed, just screams sort of entrepreneur to me. How did your time working within a really big established company impact that? Are you glad you did that, or do you wish you had sort of jumped into the entrepreneurial journey earlier?
Oh, I'm so glad and grateful for my time at Dow. So the people at Dow are amazing. And I'm talking about a company that probably doesn't exist anymore. I'm sure I've been out of Dow for 15 years, so who knows what the company is compared to what I experienced. But the people were always fantastic. And the other thing about Dow that helped me learn so much is that it really is a significant part of our economy. I was looking after some of the technology goes into refrigerator insulation, right? So that meant that I built up knowledge in terms of who are all the manufacturers of refrigerators. What does that look like? I mean, I had no idea that the biggest demand for refrigerators is actually small apartment buildings that go up, because they all need new refrigerators, and most consumers just put up with old refrigerators.
I didn't know that either.
So, I saw the refrigerator manufacturing move out of the U.S. to Mexico and elsewhere. So it's by being in a raw material company that's supplying something like, I think their supply for the refrigerator insulation was their market share is probably 40% or 50% or something insane like that. You just start to have a better feel for how that economy works. I got to go to a refrigerator manufacturing facility in China. And I saw how that company implemented the same kinds of technologies that GE was looking at, but in a completely different way, and then you start to understand a little bit more about what was happening in terms of manufacturing practices and quality and things like that. So, working at Dow just gave me a great lens into a world economy and a global economy, and to help me understand what problems are big problems, what markets are big markets, what are small markets, and just that basic level of how to look at the global economy and production and manufacturing.
Yeah. Tell me a little bit about building this company in Minnesota. What are some things that have made Minnesota a good home for you guys? Where have you run into some challenges being in Minnesota? Just talk a little bit more about that.
It's, I think Minnesota is great for its people. There's no shortage of good talent here. We have good engineers in all disciplines. We have a number of good technology-based industries that are here. And that means that you have a great place for engineers to live. I think it's a great place for families. So that also means it's a great place for engineers and talent. Our real estate is not outrageous. So that means I can get a good lease. I can get a good lab. I think some of the problems that I've run into, and I like living here, so that's great.
That helps.
It's been a great place to educate my kids, a great place for them to grow and have opportunities. So that's all good. A difficult part is that we don't have a large investment community. So I've had to definitely look outwards for my financing. Some of my financing has even come from overseas. So it's and one of the challenges with that is that when you go looking for money, um, the rest of the world doesn't necessarily think about Minnesota except for, gosh, isn't it cold there? And so they don't necessarily think about it the same way I think about it. The way I just summarized, hey, it's a great place for technical talent if you want to build a technology company. So that means there's a little bit of an uphill climb that I need to bring in terms of credibility. If I pitch a Boston investor who's been investing in additive manufacturing and say, hey, I have this new technology for 3D printing, their first assumption is that, well, if you didn't come out of this group, this cesspool of people in Massachusetts, then you probably just don't even know about it. And so you have to you have to climb that hill of convincing them, no, I really do know my stuff. That has been where my MIT credentials come in handy.
Interesting.
So the money is a problem, and just Minnesota's reputation just needs improvement. And I don't think it's warranted, but it is just something that we need to, we have to get over the flyover country problem.
Yeah.
For financing, one of the good things that came out of the pandemic is that all those investors worked from home. And so it was just as easy for them to take a video call from me as any other person they were pitching.
Interesting.
But when you go out to places like Palo Alto and Silicon Valley, you can see that there's a deal being made at every other table in a restaurant. That's something that we miss out on here.
How could we build up a better capital base to support companies like yours?
It's money begets money. That's really how it comes. So we actually have the wealth here, but the people who have the wealth are not into investing in new technologies necessarily. Some are, and I don't want to fault anyone for deciding that they want to sit on their nest egg. But I think there's a lot of fun that comes out of investing in new businesses. And that requires a little bit of a club mentality of, hey, let's all help this company that's trying to build something great. And then that is cyclical. The more everyone has success with one company, and then that company brings in exit to everyone else, that allows more of it to happen. It's a cascade.
Yeah. So, thought experiment. You guys sell for $1 billion tomorrow.
Mm-hmm.
What would you invest in? What would you do after that?
Gosh, that's a good question. I haven't even thought about it. That's something that, which is funny because I'm certainly working towards it.
Yeah.
But I think,
imagine that takes up a lot of your
that's
time.
right. It does. I think it really takes, I really believe in you invest in people. In some ways it doesn't, the what you invest in is not, it's not as important as who you invest in. My investors had no idea they were investing in a rocket company.
And you probably didn't.
And I didn't know either.
Yeah.
So what they did know is that they were investing in someone and a group of people with some good ideas on how to look at manufacturing and how to do it. And so it's, the first question is definitely the who, not the what.
Yeah. What would you say is your biggest challenge as a company today?
Right now with the pivot, it's definitely accessing the right capital. So, we're getting to the point where, more money would allow us to prove what we need to prove faster. No question. And so, one of the challenges we have because we're 10 years old is that we don't fit the model of your typical startup. A lot of people, when they see a company's been going for 10 years, they say, Cora's probably ready to retire or something, and until they meet you and see what you're doing, you can't erase that first feeling. And so we're definitely in the mode where we're regrouping on the strategy to make sure we have something that's attractive for people to invest in.
I hope they watch us, because you do not sound like someone who's ready to retire.
Not at all.
I mean, in an ideal world, would you guys do another fundraising round? And I mean, what would be your target amount of money that you'd want to raise?
That's what we're trying to figure out exactly right now is what exactly will it take financially for us to get to the point where we're actually operating as a business and not just working off of research funds. And so it's probably something on the order, it's a number that is probably between $10 and $50 million. But we're trying to figure out exactly what that looks like and whether we should be looking at that in stages. So I'm working on the financing strategy right now.
It seems like you love solving hard problems. If you could drop into another company tomorrow and say, run it for a month, nothing will happen to your company. You'll come back. Everything's the same. What company would you drop into and run for a month?
Oh, I really don't even, I don't even think about it that way. I'm just so focused on Chromatic. I like to be in places where the technical problems are what is limiting. And so I like to look at how companies are solving problems and how they're using their technical workforce and how to orient that towards good. I look at each company as having some particular challenges. I think that's why I do well in a startup environment instead of in a large company. I think the things that were starting to frustrate me at a place like Dow was that I had ideas on what needed to happen, but I couldn't, it was a lot of politics to get it where I needed it to be able to have that level of influence. And so I'm definitely at a point where if I were to drop in on a big company, it better be at a pretty high level position so I could make some changes, or else I'd feel you can hardly do anything in 30 days.
Yep.
But that's so yeah.
That's great. Shifting gears a little bit, you like to bake bread.
Yes.
How does a chemical engineer approach baking bread differently than, the rest of us?
That's a very good question. I have a culture. So I have a sourdough culture. I have a few different ones that are designed to have more yeast and more bacteria to bring in different flavors. And so I definitely think about it in terms of how do I use the fermentation process to get the flavors that I'm looking for. So it's I definitely try to understand the science behind it to influence what I do. But then it allows me, you would think that means that I have to weigh everything out gram by gram. And sometimes I do that, but other times I'm a little more it allows me to invent a little bit more.
Yeah.
So I send, December, my weekends are made up making panettone. It's very much a relaxing hobby for me in a way that I feel like I can benefit my family. And also, use a little bit of my, chemistry working in my brain. So
fantastic. Well, thank you so much for the time.
Thanks so much for having me. This is a great pleasure.
Really appreciate it.
Thanks so much.
Thank you as well to Keely Doyle, Gabe Noah, Mike Novak, Connor O'Neill, and Ali Alt for all of your work behind the scenes. We will see you next time.